in order to understand a lot of the astronomy, if you have the basic concepts of what a year is and a month and a day, then it's much easier to understand a lot of the Gemaras in Rosh Hashanah. And therefore we're going to go into the definition of what each thing is. I was once giving a shir, and I got through the year and the month, and I didn't get to the day. So the fellow went home and told his wife, I now know what a year and a month is. I don't know what a day is yet. Okay, a year we define as one revolution of the earth around the sun. It takes approximately 365 and a quarter days. However, the question is, how do you measure that, right? If you have a race, you have a starting line and a finish line. They run, you cross the finish line, it's done. If it's a round track, it's a little bit complicated. They'll keep going around unless there's some flag to know that they got to the end of a lap. So now in space, where are you going to put the flag? If you put the flag out of orbit with the Earth, then you don't have an indication that you completed a year, one revolution. So they came up with 3 ways of measuring a year. There actually is some marker in space that can be used to define the year.
Yeah.
Do the other one.
Yeah.
There's the frontal stand. You do the other one. Do the other one.
That's good enough. Then that's good enough. Okay, one way of measuring a year is using the backdrop of the stars. As the Earth goes around the sun, it puts the sun in a different grouping of stars throughout the year. The celestial sphere has about 54 mazalos in it. It encompasses the entire celestial sphere. The ones we're concerned with are the 12 that are in the path, in the plane of the Earth's orbit around the sun. As the Earth orbits the sun, throughout the year, the sun will be in a different grouping of stars. And in ancient times, being that they didn't have television, nighttime entertainment was go out and look at the stars and try to get some picture there. They had to adjust the picture, of course, and they came up with names for all the mazalos. But as you see, the sun will change position relative to the stars as the Earth orbits. So those are the 12 mazalos. Each one is approximately 8 degrees above or below the ecliptic. The ecliptic is the plane of the Earth's orbit around the sun. The Galgal HaMazalos, it's called. And each one is approximately 30 degrees, being that there are 12 of them. The entire circle is 360 degrees.
So each they move?
The stars, even though they move, that they're so far away, the movements are not discernible by Earth.
So what do you mean they change positions using the sun?
As the Earth orbits the sun, the sun is in a different grouping of stars. When the Earth is here, the sun is that group of stars. And sure, as it moves along, it'll then be in.
It's really not moving. It's just for our look. It looks like.
Yeah, but it's what we see, what we perceive, the motion of the sun as we go around it.
So we only perceive which ones? The ones that are across from us on the other side of the sun?
We cannot see the mazal of the Chodesh. The mazal of the Chodesh is the one that the sun is in. So if the Earth is here, the sun is in Shor and Taurus, you will not see Taurus. That's the one that the sun rises with and sets with. And that mazal will not be seen during the month. All the other 11 will be. The ones directly after it will be seen after Shkia, and the ones before it will be seen before Alos. And all the others will be seen throughout the night, each one rising 2 hours after the next. So that's the order of the mazalos. It's approximately 365 and a quarter days. However, it's slightly more than a quarter day. It's 365 and a quarter plus whatever number of minutes. Now that's the sidereal year, the Galgal HaMazalos. The next way of measuring is the anomalistic year. The Earth's orbit around the sun is not a perfect circle. It's an ellipse. This ellipse is highly exaggerated so you can see it. The Earth's actual orbit is much closer to a circle. In ancient times, they knew that the sun was not in the center of the orbit, but they explained it as a perfect circle with the sun off-center. That's called the eccentricity. How far, whatever you're orbiting is the eccentricity of the elliptical orbit. So in this picture, it shows that in January, we're closest to the sun. We're closest to the sun in the beginning of January at 146 million kilometers. And in July, we're 151 million kilometers away. So we're actually closer in the winter than we are in the summer.
So why is it cold?
Okay, that's the next type of year we'll explain. Now,
Why?
that's the next section. How can you measure this year?
Is it supposed to be a perfect oval?
Hmm?
It's perfect. It's not. It's the.
It's not an oval, it's ellipse. I mean, ellipse is basically, I guess, an oval. An oval,
Is it the curtain that's making the top of the thing?
Yeah,
Well,
that's like that.
It might be the
it's really
curtain.
an oval.
It's like an egg, like an egg.
It's like an egg, the circle, that's what we're saying?
No, an ellipse isn't exactly an egg. An egg is a kosher egg, and it was smaller on one side and
Right.
larger on the other. A treif. It's like a treif egg. That's an egg of a tamea. Maybe, I think. I don't know. I'm not that familiar with eggs of tameas. But how did they understand, how did they see that there was this eccentricity in ancient times? They didn't have the means to measure the apparent diameter of the sun. It was too bright. So what happens is when you have elliptical orbit, the speed changes throughout the month. As you're closest to whatever you're orbiting, you go faster because the gravitational pull is greater. Anything that's closer, more gravitational pull. The further you get, gravitational pull is less and it moves more slowly. So in actual motion, it actually is moving faster in the winter than it is in the summer. That's why the winter is shorter than the summer. Winter is 89 days and the summer is 94 days. Because we're moving more slowly. So the way they would see that they could see from the backdrop of the stars that the sun's apparent motion changed. The speed of the sun throughout the stars changed throughout the year. So therefore they knew there was a eccentricity to the orbit. However, they did not explain it with the elliptical orbit or gravitational pull. They did not know that it was moving faster. All they knew that it appeared to be moving faster because as you're close to something, it appears to be moving faster. An airplane that's flying at 20,000 feet moves very slowly, even though it's going 600 miles an hour. Whereas a car that whizzes by at 50 miles an hour appears to be moving much faster because it's close. So when they were close to the sun, they saw they were moving faster. When they were further from the sun, they saw it was moving more slowly, and therefore they knew that the Earth was not in the center of the sun's orbit, or the sun in the center of the Earth's orbit. The Rambam calls it Makom Gova Hashemish, the highest point in the year where the sun is furthest from the Earth. And the Rambam has to figure that out in order to figure out the speed of the Earth, and it's part of the Hilchos Kiddush HaChodesh. That's one of the things he has to take into account. And so there's one of the prakim there's about that, how that affects it. Okay, that's not the way we measure our years. This is 365 and a quarter days, but it's a little bit more than a quarter. Those are two ways to measure a year. The third, this is also the elliptical orbit, just some facts about the ellipse. Now the tropical year is the Tekufos, that's the year that we measure. They make globes on an angle for a reason. Not just that it looks fancy or it's easier to see the southern hemisphere. It's actually the Earth's orbit around the sun is a tilt to the rotation, the daily rotation of the Earth. The equator is defined by the rotation of the Earth. There's the two axes and the equator's in the middle. As the Earth orbits the sun, its tilt changes in position relative to the sun. So that what you have is, turn off for a second, then in the summertime, the Earth is tilted toward the sun. As it proceeds to Tishrei, the sun is exactly over the equator on Tekufas Tishrei. Then it moves along till Tekufas Tevis. When the southern hemisphere is tilted toward the sun, they have summer and we have winter. As it proceeds more till Tekufas Nisan, it is then, again, the sun is directly over the equator. And then it goes on to Tevis again. So throughout the year, the tilt changes relative to the sun. It's 365 and a quarter days, but it's approximately 11 minutes shorter than a quarter day. So this is 365 and a quarter days was the basis of Tekufas Shmuel. He said add a leap year every 4 years. And that adjusts for the quarter day. However, it's not exact, being that it's slightly less than a quarter. So Ibn Ezra says in his days, I think it was already off by 9 days in the time of the Ibn Ezra, and then by the time they actually fixed the calendar in the 15th century, the Gregorian calendar, he took off 11 days, and he, instead of having a leap year every 4 years, he would have 97 leap years in 400 years. He took out 3 leap years every 400 years in order to correct for this discrepancy, because if you add up 11 minutes a year, over 100 years, it's about 1,100 minutes, which is about 3/4 of a day. And therefore, if you take out
Sorry for
3...
interrupting. So when the Earth goes around the sun, it tilts?
The Earth
tilts?
It's always at a constant tilt relative to the plane of its orbit around the sun. It's a constant tilt.
If it's at the same tilt, why is the northern hemisphere closer or the southern hemisphere closer?
Closer has nothing to do with this. Even if it were a perfect circle, you would have the seasons because of the tilt. The anomalistic orbit, that has to do with close and far, but you could have one without the other. Even if there would be no tilt, some of the planets have no tilt, but they have an elliptical orbit like this, or their tilt is very little. Or
No, but I'm trying to figure out is why the tilt is affected by summer and winter. It's the same tilt.
what affects summer and winter is the direction of the tilt towards the sun. In the summertime, we'll flip on the light, let's see. If, let's say the sun is over there, that far end. In the summertime, you have the northern hemisphere tilted toward the sun. So they have many more hours of sunlight a day, and it's more direct. So as it goes around, then the tilt is directly in line with the sun, which is at the equator. So then it's even on the whole world. As it goes to the southern hemisphere, in the winter for us, you have very few hours of sunlight, and it's at a great angle, so it doesn't heat up as much.
Does it do with the fact that the sun is not in the center of the orbit?
No. Actually, it would be the opposite if that were the only fact, because we're actually closer in the winter. But the winter has to do with the tilt, not with how close we are to the sun. Okay, so being that there's a tilt, so the position of the sun changes throughout the year. In the winter, it's very low on the horizon, and in the summer, it goes up throughout the year till it gets to the summer where it's highest off the horizon at noon. And in the winter, you have long shadows, and in the summer, you have short shadows. So in the winter, the shadow will be much longer than in the summer. As the summer proceeds, so throughout the year, it'll go through every point down till the summer, and then back up till the winter. So from one solstice to the other, you go through 6 months, and then you go back, the same pattern, up till the next solstice, through the equinox. So that's actually what the Gemara on Yud Aleph with when did the Malachim come to Avraham Avinu? So Rashi in Chumash learns that they came on Pesach. They came on Pesach, and then the following Pesach, Yitzchak was born. So Rashi brings down the Midrash, they drew a line on the wall and said, when the sun gets to this mark on the wall, we'll come back. So if it's Pesach to Pesach, it seems to be apparently simple. Okay, it's 1 year. However, if it's Sukkot to Pesach, how does that work? Well, based on what we just said, it's fine, because the sun will get to every point in its throughout the year, every point twice. Once on its way down till the summer, and then once back on its way up to the winter. So if they came at the equinox, then 6 months later they'll be again at the equinox. If they came a week before the equinox, it'll get to that point a week after the equinox. And if they came 2 weeks before, which the Gemara ends up saying, they came 7 months, it was a 7-month time because it was a leap year. If they came 2 weeks before the equinox, they drew the line there, and then 2 weeks after the equinox, the line was in the same spot on the wall where they had drawn it 7 months earlier. And that's how it comes from Sukkot to Pesach. You have the mark on the wall work out according to the Gemara in Rosh Hashanah. Now Rashi and Chumash learns that they came on Pesach. So from one Pesach to the next Pesach is 12 months. 12 months is only 354 days. And we know a solar year is 365 days, like we just said. So it's an 11-day discrepancy. It's actually more shver. This is a kasha on Rashi and Chumash on that pshat. How do the line on the wall work? So when I was in Toronto over 30 years ago, I heard Moshe Friedman said b'shem his father, Tzvi Yehuda Friedman. He said it could be the Malach who said that was Raphael. Rafal came on the third day after Abraham had his Milah. So he said, I'll come back next year. What day? Third day after Yitzchak's Milah. Yitzchak was Nima Lishmana. 3 days later he came. It was 11 days after the solar year, the lunar year. Okay, those are the 3 ways to measure a year. You have the same 3 ways to measure a month, but there's really 5 ways to measure a month. You could have a sidereal month. That's one. Flip the light there, please. Okay, it's one cycle of the moon around the Earth till it gets the same position in the stars. That will take us approximately 27 1/3 days to do one lunar cycle around the Earth relative to the backdrop of the stars. It'll be the same group of stars. That's one way. That's the sidereal month. Then there's the anomalistic month based on the orbit. The orbit of the moon around the Earth is even more elliptical. It's got more eccentricity than the Earth's orbit around the sun. So the moon's apparent speed changes more throughout the month than that of the Earth around the sun. Therefore, at one point it's closest to the Earth, and it goes further away as the orbit throws it out. Then it gets closer again to gravitational pull, and it's moving faster. Then again slows down as it goes out again. Every month it happens, gets close, and then far, and it's approximately 27 1/2 days for that orbit. That's the anomalistic orbit. This is very important for the Gemara, Pami Baba Arucha, Pami Baba Kisaru, which we'll soon get to. So the orbit around that's the second way of measuring the orbit. The third way is based on the tilt of the Earth, when it gets to the same point relative to the Earth's tilt. Let's say if the northern hemisphere is most tilted toward the moon, you can measure a month like that. It's also 27 1/3 days, approximately. Those are the 3 ways that are the same both for the moon and the sun. Now the fourth way of measuring it is called the Draconic month. This is very important in Hilchos Kiddush HaChodesh in the Rambam. As the moon goes around the Earth, it follows basically the same path as the sun through the stars. It's called the ecliptic, the Galgal HaMazalos. It goes along the same path as do all the planets. They all go around on the Galgal HaMazalos with different tilts. If the moon's orbit around the Earth were exactly the same as the sun, we would have an eclipse every month. One, an eclipse of the sun when the moon passes between the Earth and the sun, and one when it passes between through the Earth's shadow in the middle of the month. We'd have a lunar eclipse, but we don't have an eclipse every month. Why is that? Because the moon's orbit is tilted to that of the Earth around the sun. So it means every month the moon goes higher than the ecliptic, higher than the Galgal Mazalot, and then goes back lower. It's called in the Rambam Nekudas Rosh as it goes up, and Nekudas Hazanav when it goes down. So that's twice a month it crosses the ecliptic. Once going up, once going down. Therefore, most of the time, this is a 5-degree angle, most of the time it will not be in line to create an eclipse. It'll be higher or lower. The moon's apparent diameter is approximately 1/2 degree in the sky, the same as the sun. Apparent diameter is the same. So unless it's very close to the nodes, very, very close to the Nekudas Rosh or Zanav, you will not have an eclipse. If it's close to that, then you'll have an eclipse. And there's a whole series of eclipses. It was discovered by the Kaledoi over about 2,000 years ago in the time of the Gemara. The Kaledoi were known to be great astronomers and astrologers, and they knew the exact pattern of the eclipses, and they were able to predict the actual eclipse of the moon whenever it would happen.
Why is it a bad sign if you're able to cheshbon it?
Okay, that's a Gemara in the Gemara in Sukkah.
Yeah, it's Gemara in Sukkah.
So Rav Margaret explained that in the Shir, because even though it's known, but it's still at that time period that shows that there's something. It's an astrology thing. So this is an astronomy Shir.
But but it always comes at the perfect time. It never goes out of that. It's always to be counted.
There's a cycle of the eclipses. They're
always
predicted.
predictable.
Yeah, their cycle's been known for a couple of thousand years already.
Does that angle of 5 degrees stay continuous?
No, this angle of 5 degrees is it's a continuous angle, but it moves in retrograde to the ecliptic because we said the sidereal month is 27 1/3 days. The draconic month is 27 1/5 days. So every month it will precede where it crossed the ecliptic by a little bit every month, and it'll make its full circuit in about 18 years, I think. It came out to 248 lunar cycles to make the full rotation. It's the Ramach. I told it to Chaim Kanievsky. He said, "Oh, you made the Teshbon. Very nice." So I told him that many years ago when you could.
Why does it take so long to make it full circle? Does it make it once a month?
It makes the circle around the Earth, but through the ecliptic it crosses up and down every month. But it's only about only a little bit before where it crossed the last month.
Because the angle's moving?
Because this relative to the ecliptic, it's the angle stays the same, but it's just retrograde to the ecliptic, to the Galgalas Amalas. So what you have is it'll just over the course of a cycle, it'll go through all the stars over the course of the 18 years, whatever it is.
The start and the finish point on that angle moves.
No. Now, none of these are the way we measure our month. We have 2 extra days. These are all 27, 27 and a third, 27 and a half. They're all close to 27 and a half. So that was the draconic month we just explained. Now what we measure is the synodic month, when the moon gets to be in line between the earth and the sun. There's the new moon. The moon's exactly in line. The sun is here. Now, over here it's the end of a sidereal month. The month ended, but the moon, since the earth moved 30 degrees, the moon is not going to be in the same place yet, relative to the sun. Since the earth moved 30 degrees, the moon is going to make up for that movement. So it's true, relative to the stars it's in the same place, but relative to the sun, it's not there yet. So it's going to take an extra couple of days to go from here to there. And then you have a new moon. That's the Moilad. Okay, this is very important for the Gemara.
Is that an eclipse?
That is not an eclipse unless the nodes line up. That's just a Moilad. The Moilad is when they're the smallest phase of the moon. When the moon crosses the line between the earth and the sun, that's the Moilad. But it being that there's a inclination of the moon's orbit, it could be either 5 degrees above or any number of degrees between 5 below the ecliptic and 5 above. Therefore, you won't have an eclipse more than about twice a year.
You're saying it's making a full circle really before the real Nola?
It makes a full circle relative to the stars. It's all relative to what you're measuring. If there would be no stars, then who says it's a full circle? So it's relative to the stars. It made a full circle. Relative to its anomalistic orbit, it made a full circle going through the cycle of its fastest speed and its slowest speed in the 27 and a half days. But now we have another 2.5 days, 2 days between here and here. So those 2 days aren't always going to be the same amount of time. Why is that? Because we have an orbit that is anomalistic. It's a ellipse. So the speed of the moon changes throughout the month. So it depends where in that orbit are you for it to go from here to here. How long will that take? If the moon is close to the earth at the time, it's moving more quickly. And therefore we'll get there faster. And therefore the Molad will be sooner. It might be before the 29 and a half days. And therefore the Eidim will have a greater chance of seeing the new moon because it's already more time has passed from the Molad till that night when they look for the moon. Whereas if the moon is far from the earth, at apogee, it's moving slowly, and it will take a longer time to make up the difference between here and the next spot where it's going to be the Moilad. It'll take more than 29 and a half days, and therefore the Eidim will have less of a chance to make a sighting of the new moon that month. And that's the shot, according to most Rishonim, in Pamim Baba Arucha, Pamim Baba Katsar. Sometimes it has a long path to make up from here to the new Moilad, and sometimes it's a short path, depending on where in its elliptical orbit it is.
Doesn't it pass by the sun twice a month? When it goes high and it goes low?
It doesn't pass the sun. It goes through the
Between
Galgalam.
the earth and the sun twice a month.
It goes through it goes once a month. It passes between the earth and sun, and the second time it passes between the earth is in the middle, opposition. It's the Moilad and the Nigud. So you have the Moilad there, and the Nigud is when it's halfway the other side. This one shows the Nigud.
And that's the full moon.
That the Nigud is the full moon. So this one shows that it's easier to see relative to the stars at Nigud when you have a full moon, because you could see the moon then. At the Moilad you can't see the moon. So over here it's showing that Nigud happens 2 days after the sidereal month ends, relative to the stars. Relative to the stars ends here, and then another 2 days later, it will be in Nigud, a full moon.
So why is the Milo exactly 29 and a half?
It's not exact.
So why do we keep it 29 and a half?
It's an average. What it is we do the average because that's simple. Just like we use Tekufa Shmuel as an average of 365 and a quarter, even though it's not exact, we still use it for the Saint Alumatar and Chutz La'aretz. They say it because that's something that's based on the seasons. So therefore, we use the seasons for Saint Alumatar. We use the seasons because, and since it's something that everyone has to know when to start davening, what to say, for the general populace, we use an average that's simple to figure out. Same thing for Birchas Hachama. We use Tekufa Shmuel for that. However, we use for the actual setting of the Chodesh, we use Tekufas Rav Ada Bar Ava. That we have to align it with the 19-year cycle, which is much closer to the exact. And that's done by Beis and by experts, so that the people don't figure out the calendar. It's the experts that figure out the calendar, and therefore that's not left up to the Amon Am, so that we don't have to use an average and exact. We can use something more exact. Yeah. So, being that we have the 4 seasons, throughout the year there are the 4 seasons. Now the 4 seasons don't have any months. The year has no months. Months are dependent on the moon, and years are dependent on the earth around the sun. So seasons have to do with the tilt of the earth, the tropical year, and therefore the Gemara entertains, just like we have a Saint Halamotter is based on the seasons, and obviously the Birchas Hachama is based on the earth around the sun, because that's what it is, Birchas Hachama, nothing to do with the moon. So too, maybe Tu B'Shvat, which is when the trees start blossoming, is based on the seasons. So maybe Tu B'Shvat should be based on the Tekufa. How is that? Well, throughout the year you have the 4 Tekufas we mentioned earlier. Right. Tekufas Teves is when the southern hemisphere is facing the sun. Tekufas Nisan is when it crosses the equinox. Tekufas Tammuz is when the northern hemisphere is facing the sun. And Tekufas Tishrei is when it's again crosses an equinox in the other direction, going south for the winter. So those are the 4 Tekufas. Now each one could be split into 3. So you have Tekufas Tishrei. 30 days later will be Tekufas Cheshvan, then Tekufas Kislev. These are the months of the Tekufa, and not necessarily will Rosh Chodesh come out then. So then you have Teves, Shvat, Adar. Tekufa of Shvat would be right in the middle between Tekufas Teves and Tekufas Nisan. So that, being that Tu B'Shvat is a tropical phenomena, that we're looking for the budding of the trees, it has to do with the seasons, maybe we should do it 45 days after the Tekufa, the Gemara asks. Maybe that's when Tu B'Shvat should be, and not a lunar date.
That's today's Daf.
Yeah, so that's why I'm saying it. So that's, the Gemara says, even though it makes sense, and it's logically you should, but the Gemara says, anyway, we do it lefi the lunar months and not lefi the Tekufas. Okay. Okay. All right. Now those are the 3 ways of a year, 5 months. And what are the days? There are 2 ways of measuring a day. A day is one rotation of the earth around.
I'm sorry. So that Ruch and Tzara you didn't explain is whether it's closer, moving faster, moving slower.
Right. I'll go back to it if I didn't. I thought I explained it, but I'll go back to it.
You didn't mention the Gemara when you explained it.
Okay. The Gemara says that there was a machlokes in the Mishnah. Rabbi Gamaliel said sometimes the moon is moving more quickly, sometimes it's moving more slowly. Therefore, pami baba arucha, pami baba ktsara, and therefore the average moiled is not always what you'll use, and therefore even though maybe according to your cheshbon the Edom would not be able to see the moon, but if it's 1 month where the moiled came earlier, So then it's already more time passed from the Moilad till the new moon. First of all, let's see what is a new moon. What are the Edom looking for? It's too far. These are the phases of the moon. Throughout the month, the apparent what we see of the moon is changes. In the new moon, we see nothing because the moon is always half lit and half dark. The side facing the sun is lit, and the side away from the sun is dark. As the moon progresses around the earth, we're able to see a thin sliver. We can't see the new moon because the light side is facing the sun. After it goes away a certain number of degrees from the sun, approximately one day after the Moilad, you could see a thin sliver. Before that, you can't see it. According to Rashi and Tosfos, it's 6 hours. You need 3 degrees. Since the moon goes around the earth in the course of a month 360 degrees, that means every day is approximately 12 degrees, which means every hour is approximately half a degree. So Rashi and Tosfos learned that the Gemara is simply that you need 6 hours to see the new moon, which is only 3 degrees. The Rambam and the other Rishonim learned that you need more than that. That's not Pshat in the Gemara, according to them, because no one ever sees it at that point. You need a full day, according to Baal HaMor, and the other Rishonim, it's approximately a day after the Moilad you'll see the new moon. Because then the moon is already far enough away from the sun that the sun won't obstruct it after Shkia. The sun will set first. About 20 minutes after sunset, you'll see the moon a few degrees off the horizon. As the month progresses, you'll see more and more of the crescent. It will grow larger until you see half the moon at the first quarter. Then it gets larger until you see a full moon at the Nigud. And then it starts getting smaller again, and the old moon will grow invisible as it gets close to the sun, one day before the Moilad. So there's really about 2 days you don't see the moon, the day before the Moilad and the day after the Moilad. Now when the Edom are looking for this thin sliver, obviously you're going to need a certain amount of time after the Moilad till it becomes visible. The more time you have, the easier it will be to sight the new moon.
What Moilad means when it's directly in front of the sun?
The Moilad is the conjunction when the moon is directly in between the earth and the sun. Now it's when it, at smallest phase, when the smallest phase of the moon. It might be an eclipse, but usually it won't be because it's a little higher or lower. But if you have an eclipse, then you know when the Moilad is. That's the actual Moilad. And it does not line up with what they announce in Shul. That's how you know that what they announce in Shul is just an average. It could be off up to 14 hours either way. From the average Moilad, whatever time that is, the actual Moilad could be 14 hours before or after the Moilad, which is a pretty large difference. So, being that the Edom are looking for this thin sliver, that depends on how long after the Moilad you are. If the Moilad came a couple of hours earlier that month, it'll be easier for the Edom to sight the new moon. That's Pamim Ba B'Katsari. It came out quickly. That's when the moon is close to Earth, it's moving quickly, and therefore it makes up the 2-day discrepancy that we mentioned before. Over here in the Synodic month, it makes up this time in less time. Whereas when the moon is far away, it's going to take longer for it to get to the Moilad from when it completes its sidereal month. It'll take longer to the Moilad, and it will take the first sighting of the Edom will be a few hours after the average. And therefore that's one of the things the Beis Din will have to figure out, where in the orbit of the moon around the earth it was in its anomalistic month, and based on that is the sighting possible that night that the Edom claimed they saw the moon. That's the way most of the Rishonim learn, Pami Ba Barucha, Pami Ba B'Katsara. So we were... Okay, now these phases of the moon actually have to do with yesterday's Parsha also. As the moon goes around the earth, it grows until it's a full moon. It grows from nothing to a full moon. That takes about 15 days from the Moilad. So until then, you'll see the moon in the sky during the day. The moon will be up before the sun sets, because at a full moon, the sun will set and the moon will rise at the same time. That's Nigud Amiti. That the Gemara says is when the sailors in the ocean, they don't know when Beis Din was Mekadosh the Chodesh. They said you have to get rid of your chametz on the 14th day of Nisan. How do you know it's the 14th day of Nisan? when you see that the moon is rising at sunset, or the moon is setting at sunrise, the Gemara says, which is the same phenomena, you have actual nigud, you'll know you're 15 days from the Moilad. So we have to get rid of the Chumetz on the 14th day. So why it's just 15 days from the Moilad? Because, like we said earlier, the Edom can only see the moon one day after the Moilad. So, being that they see it one day after the Moilad, it's the 14th of the month that you'll have a full moon, when it was done al pi riyah. So you'll have the full moon on the 14th day, and that the sailors will have a clear view of the horizon on both sides, no obstructions of mountains and buildings. So they'll know that the full moon rising at sunset, or the full moon setting at sunrise, is nigud. That's the soivsman for getting. They have to be mevarer the chametz for Pesach. Now, the day after that, the moon will not rise during the night. It will only rise, and the moon will not set during the night. It will set after the sun rises. Over here, the person standing at this point on earth will see sun set and moon rise. This person standing at this point of the earth will see the sun rise and the moon set. Now, as the moon moves to the 16th of the month, at sunrise, the full moon will still be in the sky. Now, the Malachim came to Avram Avinu on Pesach, and then they walked that night to Sodom. They spent the night with Lot, and then the next morning, which was already the 16th, Hashem destroyed Sodom. So Rashi says he destroyed Sodom at a time when you have a full sun and a full moon in the sky, because it was the 16th of the month. So to the east they saw the rising sun, and to the west they saw the setting moon in the sky. They were both full in their tekufa, and that's why Hashem destroyed it at that time, so neither one could say our Avodah Zarah would have protected us. Now, this is also very nogea to Kiddush HaChodesh, because you could only say Birchas HaLevana, Kiddush HaLevana, until the middle of the month, while the moon is growing. We want to make the bracha on something that's growing, it's riboy, not something that's already getting smaller. So there's a Chuvas Chasam Sofer, you can actually say it on the 16th of the month, because on the 16th of the month it's not discernible, that thin sliver of the moon that's missing. And he said, he based it on, there was a ruling of a Rav, it was a cholera epidemic in another city, and the Shaila came to the Rav, and he said it was cloudy the whole month, and then the Matzoi Shabbos, it was the 16th, and they wanted to say Kiddush Levana because the school that they wouldn't die, so he allowed them. And then the Shaila came to the Chassam Sofer, and he said, Ein mas nichano, so he paskined, the Rav paskined, and he backed up the Rav's psak. But it's mashma lechachila, maybe the Chassam Sofer would not have paskined that way, because there's a Beis Yosef that says, if there's a likoi levana, if there's a lunar eclipse, then you can no longer say Kiddush Levana. What's a lunar eclipse? When the full moon passes through the earth's shadow, you know that it's half the month. You know that after that the moon's starting to get smaller. So if there's a lunar eclipse, you can no longer say Kiddush Levana. That's the Beis Yosef. Now, it would seem simple to me that you don't actually have to see the lunar eclipse. If somebody else was outside and said, I just saw the lunar eclipse, you can no longer say Kiddush HaChodesh either, because you now know the moon's getting smaller. The same would be true if somebody called you from Eretz Yisrael and they saw the lunar eclipse, even though here it's still daytime and you didn't see it, but you know what happened. Well,
What's the lunar eclipse?
The lunar eclipse is when the moon is blocked out by the shadow of the earth. Twice a year the moon passes through the earth's shadow, and you don't see the moon. So the reason is that lunar eclipse is a sign of nigud. Well, the Gemara gives another sign of nigud. If you see the moon rising at sunset or the moon setting at sunrise, that's another sign of nigud. If that's a sign of nigud, you can no longer say Kiddush Levana after that happens. Now, being there are 4 points on Earth, as the Earth spins, there's as the Earth spins, it goes through four major points. There's a line of Chatzos HaLayla, facing away from the sun, Chatzos HaYom, facing toward the sun. There's a line of Shkia and a line of Zricha. So as the Earth spins, it's going through those four lines. So there's always a line of Shkia on one side and a line of Zricha on the other. Wherever the Nigud happens, anyone standing on that line will see the moon on one side and the sun on the other, and they'll know the actual nigut happened. So the nigut is visible every month for millions of people on Earth. And therefore, the Sov Zman Kiddush Levana should be nigut amiti. Nowadays that we have communication, we can always find it out, and also you could just ask your cell phone what time is nigut amiti this month. And therefore, since it's well known, many of the luchos started to put this on as the Sov Zman Kiddush Levana, and I hold you could even use it lakula on a month where the nigut comes after the average. You could still say Kiddush Levana even until the nigut amiti.
What is that called in astronomical terms, the nigut?
Opposition, true opposition of the moon. That makes. Okay. Now there's a very cryptic Gemara which is based the date line. There's a Gemara that says the new moon, it's visible 6 hours for them, 18 hours for us. It's invisible for them, and the old moon's the opposite. It's 18 hours for us, 6 hours for them. It's Rashi and Tosfos really don't explain the Gemara astronomically. It could be Rashi could be fit into something, but I don't think that's what Rashi meant. But the pshat that's the easiest to understand is the Baal HaMor. The Baal HaMor says, well, it's an obvious fact that since the Earth is round, you'll need a dateline. Why do you need a dateline? Because if two people were to travel around the Earth in opposite directions, then one will have an extra shkia and zricha more than the other. He'll have an extra sunrise and a sunset that the other one didn't have. So obviously they're going to have a different count in days if all it's based on is sunrise and sunset. There's got to be somewhere on Earth where the date changes and it goes back to the previous day or ahead to the next day, depending which way you cross it. So there's a need for a dateline. Now, the Baal HaMor says, nowadays we don't have sightings of the new moon. We're not Mekadosh the Chodesh al Piriya, but there has to be some semblance in the way we set our years to the way they were Mekadosh al Piriya. In the days that they were Mekadosh al Piriya, the Riyah had to be within approximately a day after the Mailad. The Gemara says 6 hours after the Mailad, you cannot have that day be Rosh Hashanah. If there's not an extra 6 hours left in the day, that day will not be Rosh Hashanah. You'll have to push it off to the next day. It's called a Mailad Zaken. It pushes off the day of Rosh Hashanah. So the Baal HaMor explains this, because if you have 6 hours left in the day in Eretz Yisrael, where does the day end? Well, as the Earth spins, anything that's west of Eretz Yisrael still has day. So the day may have ended in Eretz Yisrael. It may be already after Shkia, but in Europe it didn't end yet. Okay, so Europe ends. England didn't end yet. America didn't end yet. So where does it end? So he says the day ends 18 hours after it ends in Eretz Yisrael, at the edge of the Asian continent, at the edge of China. That's where the day ends. It's approximately 6 hours to the east of Eretz Yisrael, 18 hours to the west. Therefore, any island that's right at the date line, the halachic date line, or if you're in a boat on that line, you'll be able to still sight the new moon while it's Rosh Hashanah, because the Mailad Zaken is 6 hours, so that means you already did 6 hours in Eretz Yisrael before it ended there, and then 18 hours after that it ends on the last spot on the world, which means they'll have 24 hours, and they'll be able to see the new moon that day still. That's the Baal HaMor's basic yesod.
You will see it on Erev Rosh Hashanah or on Rosh Hashanah?
The Rosh Hashanah. It has to be, if the Adam see the
Well,
moon.
technically somebody could have seen it on Rosh Hashanah.
Yes. If the moon is sometimes visible even before Shkia, but usually it's not in the new moon. But there are times you could see. So that's what the Baal HaMor bases it on. Therefore, you'll have somewhere in the world that has 24 hours from the Mailad till the end of the day, and that day can then be Kavua Rosh Hashanah al Pi, the calendar that we use. Now, he bases on the Gemara. 8 is the 6 hours and 18 hours. He explains that means if there's always somewhere on the world that will be the first ones to see the new moon. This is the line of Shkia. So as the moon goes around the sun, when the moon first becomes visible, it will only be visible to the people who are standing on the line of Shkia. Right after Shkia, 20 minutes after, they'll be able to see the thin crescent. So let's say Eretz Yisrael were the first ones to see the new moon. China didn't see it because before that it was too close to the sun. The brightness of the sun will obstruct the view. They'll first see it 18 hours later. And it says Lididan means the edge of China. So they'll see the new moon 18 hours after Eretz Yisrael. The new moon will be visible to 18. So the first 18 hours after its visibility, it will be invisible to them because they won't have Shkia yet. Whereas if China were the first ones to see the new moon at the edge of China, then Eretz Yisrael will see it only 6 hours later. Because at the time they saw it, Eretz Yisrael, it's in the middle of the day. The sun will blot it out. It's too bright. 6 hours later, after Shkia, you'll see it in Eretz Yisrael. That's, for them, it's 18 hours, and for us, it's 6 hours. The opposite is true with the old moon. After the moon makes its revolution around the earth, it's on the opposite side. Now at sunrise, someone will be the last ones to see it. Let's say it's China's the last ones to see the old moon. So Eretz Yisrael won't see it after that because it's already too close to the sun. The last time they'll have seen it was 18 hours before when they had sunrise. Whereas if Eretz Yisrael were the last ones to see the new moon, China will have last seen it 6 hours before that. They will not see the last 6 hours of the old moon. So that's what, for them 18 hours, and for us 6 hours, and it's opposite for the new moon and the old moon. That's the sheet of the Balamor, and therefore the date line is at the edge of the Asian continent.
Where's Hawaii?
Hawaii is in the Suffolk.
Why isn't it 24 hours?
In the sun.
There's a 2-day period?
Hmm?
You said there's a 2-day blackout period?
One day before the Moiled and one day after the Moiled.
So where is 18 hours?
That's in addition to the day. That's for somewhere on Earth. But if you were not at the precise location that could see it first or last, then it would be another number of hours till you get to your Shkia or your Zricha, depending on whether it's the new moon that you're looking for, the old moon. And that's why it's
really 18 or 6.
18 or
It's
6.
not a whole day before, whole day after.
No,
For somebody, it could be 18.
it's always 1 day plus that. It's 1 day from the Moiled or before the Moiled, plus an additional depending on where you are.
Additional 18 hours, that means it'll be 2.5 days you don't see the moon?
1 3/4 day. 18 hours is 3/4 of a day.
Plus a day.
Yeah, that's
No, that's
a
if you
day.
count from the day before. But when the new month,
They-
it's only a day plus.
On the new moon, if Eretz Yisrael,
From the
From the
moon.
saw it's 2 days.
Eretz Yisrael is the first ones to see the new moon, let's say. So they're at Shkia
So when was the last time they saw it? The last time they saw it was
2 days earlier.
2 days earlier.
2 days earlier.
So
2 days
what
is
is
6 hours.
2 days, well, depending,
At least 6 hours.
because it has to go through the day. They start at Zricha, so 2.5 days. It was at Zricha. The old moon's only seen at Zricha,
That they couldn't
and the
see
new
the
moon's
moon.
only seen at Shkia.
2.5 days they don't see the moon.
Right. So, but in addition to that, those who are after Eretz Yisrael won't see it for another 18 hours. At the edge of China, they won't see it for another 18. So they'll first see the new moon and a day and 3/4 after the Moiled. So that means a quadrant. This is the way that Chazon Ish learns the date line. Whereas Rav Tukachinsky learns it's just 12 hours from Eretz Yisrael, and you draw a line on the opposite side going through the longitude lines. And that means a quadrant of the world is a machlokes between the Chazon Ish and Rav Tukachinsky. And Rav Moshe told my shver not to stay in Japan go to the mainland for Shabbos. And people in Australia, there's a certain island that they don't go to on Sundays from Melbourne, because if you cross the bridge, then you're going into Shabbos. Because the mainland, it's already Sunday, but he was once going to go. My friend told me he was planning to go Chol HaMoed Sukkot the first day. And he said, "Oh, I'll have a problem with Sferis Heimer." Sferis Heimer? I'll have a problem with Yom Tov. Just told me that yesterday at his house.
So what do you do for Hawaii?
Oh, what do you do for Hawaii? This depends on who you ask. In California, they usually go from Los Angeles to Hawaii. When I was there 7.5 years ago, I heard there's different opinions of what to do. And some people are machmer both days, and there was a family that was going to Hawaii for Pesach. That year it came out on Tuesday, Wednesday. So the first days are Tuesday, Wednesday. Then Shabbos is Shabbos, and then you have Monday, Tuesday, the last days. They decided they were going to be machmir, so I guess they did the first days Monday, Tuesday, Wednesday. Then Thursday was Chol HaMoed. Friday, Shabbos was Shabbos. Sunday, Monday, Tuesday was Yom Tov, and they're never going to Hawaii again. Which isn't so bad. Okay. How much time do we have? We'll do
9 minutes.
Okay, so we could do a little more. Okay. We'll try to do the shot of the Rambam in Pamim Ba'arucha. This Gemara we have to do first. There's one more.
I think we have to just look at the words.
Now, this is very important for a Gemara, and there's a stir in the Bryces the Gemara brings. One of the things they asked of the Edom, did the new moon set before the sun or after the sun? Looking on the western horizon, was it before the sun or after? Meaning further north or further south? So the Gemara brings two prices. One says if they said north of the sun, they're believed. If they said south of the sun, they're not believed. And the other says the opposite. South of the sun, they're believed. North of the sun, they're not believed. So why is that? Okay. The Earth, as it spins, creates the setting and the rising of all the planets in the celestial sphere. So anyone standing at the equator, on the equator, will see everything rise and set perpendicular to the equator. Anyone who's further off the equator will see it setting on an angle relative to how many degrees he is off the equator. For every degree he goes off the equator, the setting of the planets will be 1 degree more. So you see, if we're at like 39 degrees over here, what about 41 degrees over here, I think. So the sun will rise 41 degrees south of perpendicular, and it will set 41 degrees on an angle south of perpendicular. Now
In the winter.
all the time, all year.
All
The
year?
position on the horizon changes from summer to winter, but the number of degrees, the angle at which it rises and sets is a constant. Now, we said before that the ecliptic is the orbit of the Earth around the sun, which creates the ecliptic. So the apparent view from Earth is that the sun goes around through the stars. What the sun does in 1 year, the moon does every month, the sidereal month. So the moon moves much faster, it's much closer. So the moon always, after the Moilad, it precedes the sun by 12 degrees before we see it. We need a full day, which is approximately 12 degrees, right? 360 degrees in a month. So it's a little bit more than 12 degrees. And then the moon becomes visible. So the first night of the Moilad, when the moon is visible, after the Moilad, the moon is visible, the moon is already ahead of the sun by 12 degrees. The sun will only get to the spot where the moon is in about 2 weeks later, 12 days later. So if it's Tekufas Teves, when the moon is south, the sun is at its lowest point, the moon, having passed the sun, will already be further north than the sun. So the moon will set on the horizon on a spot further north than the sun will set. And that will be true throughout the winter and the spring until the middle of the summer. The moon generally precedes it by 12 degrees the first night that it's visible, at least 12 degrees, minimum of 12 degrees. So it's about 2 weeks till the sun gets to that point. The moon's ahead of the sun will get there 2 weeks later, and the sun until then will be setting south of where the moon sets. So from Tekufas Teves till Tekufas Tammuz, the moon will be setting north of the sun. Whereas the opposite is true from the summer till the winter. In the summer, the sun and the moon are at the highest point above the equator. But this is the summer here. So, and as it goes south, the moon will be setting further south than the sun sets, because the moon has preceded, it's past the sun. The sun will only get there in 2 weeks. The sun is still setting on its furthest south point, its furthest north point, and therefore the moon will appear to set further north along the horizon than the sun. That's what the Gemara means. That's what the Yerushalmi Pshat is, the Rabbeinu Hananel brings it. Even though normally the Gemara, Mosach Shami means the winter and Mosach Chama means the summer, over here it means from the solstice till the solstice. You have a person standing in the northern hemisphere. At the summer solstice, the sun is at its highest point. The moon has already gone along the ecliptic further, and it's over here setting. It's going to be lower down, and it'll set south of the sun Whereas the opposite is true in the winter, when it'll all be over here, the sun will be setting at its lowest point, and the moon, having passed it, will be setting slightly further north from the summer till the winter. Now he said there's an inclination to we have the orbit of the Earth around the sun to the ecliptic, and then we have the equator. Since there's a 23.5 degree inclination, there are 2 points where they'll bisect. You have it in the spring and in the fall. Tekufas Teves and Tekufas Nisan, the sun will be in the center. But even when you don't have the Tekufa, you have the celestial equator and the Galgal HaMazalos. Those two great circles bisect at those 2 points. Now, in Tekufas Tishrei, which is right over here, this side, because this is the equator, the green one's the equator, and the blue one is the Galgal HaMazalos. So in Tekufas Tishrei, the equator is
No,
what...
the blue one's the equator.
No, the green one's the equator. So in Tishrei we said the Galgal HaMazalos will be inclined to the south of the ecliptic. Right? The green one is the equator, and the blue one is the Galgal HaMazalos. So this over here is, on this side it's, just a minute, here, yeah, okay, this is Tishrei over here. So in Tishrei, right, so the equator is the angle of the Earth's, of the sun's set will be parallel to the equator. So if you have the equator like that, so the ecliptic is inclined to the south of the equator. Whereas if you have it in Tekufas Nisan, the equator is once again the green one. It's the opposite. The ecliptic is inclined to the north of the equator. Right? Right. In Tishrei, the ecliptic is inclined, the blue is the ecliptic, it's inclined to the south of the equator. And in Nisan, it's the opposite. It's inclined to the north of the equator. So, if you see the new moon in Tishrei, it's generally going to be south of the ecliptic, south of the equator, lower down on the horizon. Whereas in Nisan, it's the opposite. So,
5 degrees tilt of the moon's ecliptic path affect that?
yes, that'll affect it greatly. We'll get to that hopefully in a minute. So, at the equator, everything goes perpendicular to the horizon. Now, in Tekufas Nisan, it'll be 23.5 degrees north of directly east. In Tekufas, not Nisan, it's Teves. Teves, and this is Teves, when it's 23 south of east. And this is when you, as you go to Yerushalayim, so it's on an angle. It's not going to. It's still perpendicular. It's still parallel to the equator, the setting of the moon and the sun, but it will be off on your horizon. It'll be at an angle relative to the number of degrees you are at latitude.
Yerushalayim is what?
32. So over here we have Tekufas Nisan. So this is the line of the setting of the sun, parallel to the equator. The ecliptic is going to be inclined to the north, we said in Nisan. So therefore the moon, being 12 degrees away from the sun, will be high up in the sky. And even if it's 5 degrees north or south, it's not going to make much difference if it's 5 degrees north or south of the ecliptic. Whereas in Tekufas Tishrei, it's the opposite. The ecliptic is inclined to the south of the line of the setting of the sun, which is parallel to the equator, so it's inclined to the south. The moon can be up to 5 degrees north or south of that. Now, if the moon is very close to the horizon, you have very little time from Shkia till the moonset. From sunset to moonset, it won't be much time, because it's already close to the horizon. So in the summertime, in Nisan, you'll have a long time from sunset till moonset. Whereas in Tishrei, you have a very short time from sunset to moonset. In addition, the 5 degrees will make a great effect over here. It'll put it very low on the horizon. So that's what the Rambam says. He takes all these different cheshbonis into, this is one of the cheshbonis that he uses, and he has to figure out where the moon will be relative to its 5 degree inclination, the Nekudas Rosh and Zanav that we mentioned before. Where is it relative to the ecliptic? How far away from the sun it is? And therefore you'll know how much above the horizon. When it's much above the horizon over here, you'll have a long time from sunset to moonset. Therefore, this is Pamim Ba Ba'arucha. Ba is Bias Hashemesh, is the setting of the sun. Sometimes it'll be a long time till sunset, from sunset till moon. But sometimes the sun will set, and then the moon will have a long time till it sets. The moon will set Ba'arucha on a long path. So the Rambam learns that if it sets on a long path, you'll have more time to see it after sunset, and it's easier to see. Whereas in the fall, when it's on a short path, you won't be able to see it. So in the best scenario, you'll be able to see it 18 hours after sunset. After the Moilad, you'll be able to see the new moon after sunset. And in the worst scenario, it could take up close to 2 days from the Moilad till it's far enough along to have enough sufficient elongation and be high enough in the sky to see it after sunset. So the Rambam Shpat actually comes out opposite of all the other Rishonim in Pamim Barucha. The other Rishonim say Pamim Barucha, it'll be a long month, and therefore the Moilad will be later, and you'll have less of a chance to see the sun. Whereas in the Rambam, Pamim Barucha, it's a longer time till sunset, till moonset, and therefore you'll have a greater chance to see the new moon. Okay.